Hello, my name is Mark, and today we're going to be going over the continuing education, algebra, and functions practice problems. We are going to be graphing linear equations to test statements. This, my friends, is my favorite part of the test. Can you tell? I'm just kidding. Okay, this is an extension of my practice test that I made, the IBEW full-length algebra and functions aptitude practice test. This is practice test 1. Make sure to go over that practice test before you start these additional problems. Specifically, I believe this is going to be question 16. Yeah, we have question 18, 17, 16. So not 16, but we got 17 and 18 over here. And there's probably a couple more. So go over those questions, figure those questions out, try your best to understand them before heading over here and doing the additional questions that I've made. Make sure that you like the video and subscribe to the channel if you are not subscribed. All right, let's just start. X equals 2y minus 10. Consider the following formula. This is exactly how it's going to be written. And then you're going to be given these statements here. When the value of y is greater than 5, x is positive. When the value of y is less than 5, x is positive. When the value of y is greater than 5, x is negative. When the value of y is less than 5, x is 0. Okay, let's work this problem out. First, notice the problem. Look at it. Look how it's written down. We don't want it written like this. We want it to be written in slope and intercept form. And slope-intercept form is y equals mx plus b, where m equals the slope and b equals the y-intercept. Okay? This is how we want things to be written, because for this problem, we will have to graph it. Okay? So let's just erase everything here and let's just start working out this problem. So x equals 2y minus 10. What can I do to isolate everything? Or what can I do to rewrite this whole problem, this whole expression into y equals mx plus b? So let's go ahead and do that. We're going to plus 10, plus 10. X plus 10 equals 2y. We can also rewrite it as 2y equals x plus 10. So we're already there. This is written in slope and intercept form. We can go a step further and do this. Divide everything by 2. And then we have y equals 1/2 x plus 5. What is 10 divided by 2? 5. What is x divided by 2? It's 1/2 x. So now we have our equation that we can graph. We can also graph this by figuring out the x and y intercepts, which is our next step. Okay, for the sake of this video, and so that we can solve this problem the fastest way, I'm going to be using 2y equals x plus 10. I'll also solve the problem using y equals 1/2 x plus 5, because this makes sense on a graph, right? Just from looking at this problem too, we already know what the y-intercept is. And when you want to figure out the y-intercept, just set x to 0. If we set x to 0 right now without doing any math, we could just know that 0 times 1/2, anything multiplied by 0 is 0. We're left with 5, so y equals 5. And we know that the y-intercept is 0, 5. right? Because how to write a point on a graph is x comma y. X was 0, y became 5 when we solved that equation, right? But it just looks nicer here because we're not using any fractions. We could do the same thing. If you put x as 0 or set 0 or set x as 0, we have 2y equals 10. Let's just write that down. 2y equals 10. Divide by 2, divide by 2. Now you have y equals 5, and we just refer back to here where our point on the graph, the point is 0, 5, right? Now all we need to do is find the x-intercept. And the x-intercept, all you need to do is set y to 0. Okay, so remember 2y equals x plus 10. Okay, and then also I'm going to write here on the side so I don't forget y equals 1/2 x plus 5. Okay, so we already have our y-intercept, and I'm going to make that in red. Okay, I'm just going to put this off to the side or down here at the bottom where I'm not going to write. So we know our y-intercept, our first coordinate plane, our first coordinate, is it coordinate or just, I'm just going to use point. Our first point on the graph is 0, 5. Okay. Now we want to know the other point in our graph, which is the x-intercept. And remember, to get the x-intercept, we're going to make y 0. So our equation writes as such: 2, 0 equals x plus 10. That equals 0 equals x plus 10. Minus 10, minus 10. We have x equals negative 10. You see what I did there? I could have just wrote negative 10 equals x, but you could just switch these. These are interchangeable when you have it, when you have these like this. Okay, you could just switch it on the go. So now we have our x-intercept, which is now negative 10, 0. Now we have 2 points that we could graph. So now our next step, which is to graph. But before I graph, I am going to plug in I'm going to plug in 0 for y on this equation here, y equals 1/2 x plus 5, just to show you that we're going to get the same answer. We're going to get negative 10 as x. So y equals 1/2 x plus 5. I'm going to set 0 for y, and then we have 1/2 x plus 5 minus 5 minus 5. Negative 5 equals 1/2 x. To get rid of this fraction, we're going to have to multiply both sides by 2. So 2, because it's going to be 2 times 1. It's going to equal 2 over 2 equaling 1. And then 2 times negative 5 is negative 10. These cross out because remember this multiplied by this equals 2 over 2. Those cross out. And then we're just left with x equaling negative 10. Okay? Perfect. I hope you understand that. I hope that you know that you don't have to completely isolate the y. It'll be good to isolate the y. It looks cleaner, but you don't have to. Okay? Now we draw a graph. Please excuse how I'm going to draw this graph. Okay? It's going to be pretty ugly. Okay? And I'm not going to be perfect here. Okay? I'm going to go like 0, 5. So 0, 5, we start here at the origin and we just go up 5, right? You can write like this if you wanted to. I guess let me write it out so you can get it. 1, 2, 3, 4, 5. 0, 5. So there's a point right here. And then we have negative 10, 0. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have this right here. So then now our line is going to be like this. Oh, I got it. Okay, perfect. Okay. And this is the x-axis and this is the y-axis. Okay. So now we're going to read each statement. When the value of y, right? When the value of y is greater than 5. So remember the 5 is here. This is 0, 5. And this is -10, 0. Okay. And you have like 1, 2, 3, 4. So when the value of y is greater than 5, so anything greater, let's choose this one right here. And this is 8, I believe. 5, 6, 7, 8. So we have 8. So I'm going to go over this way, right? Because I want to touch my line. And we know that x is positive. It ends up to be positive. If we choose another number, let's say 9, right? Again, we go here to our line. It's going to be positive. The x value will be positive. And if we keep going, we'll see that it's always going to be positive to infinity. No matter what we do, anything past 5. So when the value of y is greater than 5, x is positive. So we could stop right here and be like, yo, that's the right answer. That's it right there. But let's go see the other answers or the other choices. When the value of y is less than 5, so anything less than 5 on the y-axis, when the value of y is less than 5, so let's just choose 4, right? X is positive. Well, if we choose 4, and I'm going to use a different color here, I'll use green. If we choose 4, because this value is less than 5, we see that the x value is negative. Doesn't matter what it is, but it's negative, right? Because I can't go this way. There's no line. There's no way that the 4 could touch anything, right? There's no line this way. But if we go this way, it touches here, goes down here, and it's a negative value. If we chose, let's just choose an obnoxious number here. I don't know what this is, but let's just choose it, right? It's still less than 4. And if we keep going this way, it's going to be negative. So when the value of y is less than 5, x is positive. This is not a true statement. This is false. So I would cross it out. Okay. When the value of y is greater than 5, x is negative. We've already proved that anything greater than 5 is positive, right? So we could rule this out. When the value of y is less than 5, x is 0. Anything less than 5, that's incorrect because the only way that we can have x to be 0 is at the y-intercept, which is at 5. If it said when the value of y is less than or equal to, right? Or I don't know. I'm going to confuse myself there. When the value of y is less than 5, less than or equal to 5, x is 0. It could be true because the 5 is at 0 because we can choose 5. But I don't think that will be on the test. It could be, though. It could be. But we know from this statement, when the value of y is less than 5, so anything less than 5, x is 0. That is incorrect because 5, when the point 5 is chosen, that is 0. So we can cross that out. So for the sake of the test, right, I would have already been like, all right, this is it. Okay. I love it when A is the answer. Sometimes on the test, though, I would randomly choose let's say like C, and then start testing. If you're going to choose A and keep going and testing A, do that for all the problems. If you're going to test C and then if you're going to test C, only test C for the remaining problems with questions like this. I want to say that these aren't that hard. They're just time consuming because you have to draw out a graph. There is a way to do it without graphing, and I am not good at it. Okay, I would have to do further research on how to do it. I remember going through it and making sense of it, but I found that visually graphing helps a lot more. And I really want, when I take these tests, I want to get the answer right and I want to visualize it. I'm a visual person, so graphing just makes sense to me. But on my next videos, if you guys really want it, I'll do my best to explain it. Just let me know in the comments. I'll do some more research. It may help you on the test, or what I believe may happen is it might confuse you on the test, which I don't want to do. So I'm going to stick to graphing for now. Okay, moving on. Next question. Consider the following formula. X equals 3y minus 4 minus 2. Then we have all these statements here. So the first thing we want to do is rewrite this whole expression into y equals mx plus b. How do we do that? First, we must solve. Okay, we're going to write everything down. Y minus 4 minus 2. And then we're going to distribute this 3. X equals 3y minus 12 minus 2. Then we're going to go and combine. So minus 14. And then we have our equation, actually. So we're going to plus 14 plus 14. Then we have 3y equals x plus 14. This is the equation I'm going to use. I'm not going to go further. I don't want to deal with the fraction. So I'm going to write it up top here. And let's go ahead and solve to get our x and y intercepts. Remember, to get your y intercept, you're going to set x to 0. So 3y equals 0 plus 14. And then we have 3y equals 14. Divide by 3. Divide by 3. How many times can 3 go into 14? We have an improper fraction here. How many times can 3 go into 14? That's going to be 4 times. And then we're left with 2 over 3. If we were to, if we want to rewrite this to an improper fraction, we would multiply 3 times 4 plus 2. So I'm going to rewrite it again. And that equals 12 plus 2 equals 14 over 3. Okay, good. That was a refresher for even me. Now we have, for our y-intercept, we have 0, 4, 2/3. Again, to get our y-intercept, all you need to do is set x to 0. Okay, now to get our x-intercept, we're going to set y to 0. Okay, so 3, 0 equals x plus 14. 0 equals x plus 14. Minus 14, minus 14, we get x equals negative 14. So now our x-intercept is negative 14, 0. Okay, now we have everything that we need to graph. Okay, so bear with me as I write this graph. And before I made the graph and I put the little tick marks, now I'm not going to do that. Okay, I don't want to do that because I want to show you that you don't need to make your graph all perfect. Okay? We have 0, 4 2/3. I'm going to put it like right here. Okay? And then I'll label it though. 4 2/3. Okay? And then we have negative 14, 0. I'll just put it over there. 14. And then I'm going to put a line. Boom. Okay. Now I'm going to start reading each statement. When the value of y is greater than 4, okay, I'm going to choose 4 and put it like really close to the 4 2/3 because it's right below the 4 2/3, right? This is 4. Then x is positive. Excuse me. When the value of y is greater than 4, x is positive. So, okay, this one's tricky, right? Because if we chose 4, anything less than 4 2/3, right? So like, let's say, anything between 4 and 4 2/3, if we look at it on the graph here, I'll make this green, right? I'll put like this point right here. It could be 4.5 or 4 1/2. It's actually negative. It's really small, but it's negative. Okay? It's not until we chose a number like 5, because this is also greater than 4, and then it flips to positive. My gosh, for me to say positive is very difficult, especially on camera. But what I'm trying to say here is you have to watch out for stuff like this, because there's this little portion of the graph where our x value is negative, and then it becomes positive when we go above the 4 2/3. That's really all you need to know for this. So like, for example, for this, I would put a line. That's a terrible line, but I would put a line right at the 4 2/3, and then I would start putting, or then I would start testing each statement, and then putting them on the graph and saying like, oh, okay, when it's below this line, it's negative. When it's above this line, it's positive. It is a positive value. So let's go ahead and go with B, or we know that A is wrong because a little portion of it, a little slither of it is negative. So when the value of y is greater than 5, x is positive. So greater than 5, so this is 5, right? This point right here is 5. So let's choose this point right here. I don't care what it is. We just chose a point that's greater than 5. This could be 99 for all I care. But if you look, it's positive on the graph. If we chose 100, positive on the graph. So B is correct. Let's test the other ones though, for the sake of the video. When the value of y is less than 5, x is positive. We know this is incorrect. Value's less than 5. So that's 4 2/3 over here on this line, and less than 5. So let's say 5 is right here. So 5, yes, is positive, but anything below it becomes negative. So it says less than. So let's choose this point right here. Let's say that this is negative 10. This doesn't go this way and meets up with the line. No, we have to go this way. And then we see that when it finally touches, it becomes negative. And it becomes negative all throughout. It doesn't become positive. So this is incorrect. When the value of y is less than 4, so this is 4 2/3, less than 4, x is positive. Well, no, that's incorrect. It's just like this. So we keep going down. All these values are negative. All the x values are negative anytime the y values are less than 4. I hope you're tracking, because this is incorrect. B is correct. Okay, this one was kind of a medium or this is an easy problem. The thing is, you have to manipulate the expression to make it y equals mx plus b. That's about it. Everything else stays the same. The graphing and also trying to figure this stuff out right here. I hope this makes sense. I really hope it does, because it took a little bit of time for me to like make it click. So we have one last problem before I leave. Question number 3. This is a monster. This is going to be hard. But the thing is, this is going to be hard, yes. And I believe this question will definitely be on the test. Okay, I've seen this one before. I've either seen this a lot on iPrep, or I've seen this one actually on the test, a problem just like this. And the reason why they're so hard, problems like this are so hard, are because you're going to have the A and B replacing the Y and X, respectively. Also, you're going to have inequalities. These are inequalities in your statements. Moreover, you're going to have to test the B's and the A's, or the X's and the Y's. Okay? In our last problems, we've only tested if Y, then X. We'll have to, in this problem, it's going to switch. It's going to be if B, then A. And then if A, then B. You feel me? This is going to be hard. Okay, it's going to be confusing, and I might mess up. But we're going to get through this together. Okay, so the first part's going to be easy. We're just going to write the problem in y equals mx plus b. We are going to rewrite the expression in mx plus b form. So a equals negative 2, b minus 3 plus 5, right? We're going to distribute that negative 2, and then we're going to get a equals negative 2b plus 6 plus 5, and then we're going to get a equals negative 2b plus 11, and there you go. We have our expression in y equals mx plus b. So in our mind, we could think of it as y equals negative 2x plus 11. That is something that we are familiar with. We are not familiar with this a and this b, or I'm not familiar with that. I don't know about you, but I'm not familiar with something like this. I'm familiar with something like this. Okay, what we can do is just rewrite the whole formula and statement, right, with x's and y's. So we could go like this. This is y, this is x. That's a y. Y, x, right? We could do that, but that is time consuming, and we don't want to do that. So we have a equals negative 2b plus 11. And after this, we are going to find the x and y intercepts, or the a and b intercepts, b or a intercepts, actually, if I want to do it respectively. But you get what I mean. Okay, let us find where the graph intersects at a. Okay, and that is when we set b to 0. So we have a equals negative 2, 0 plus 11. Our coordinates will be written in b and a form, which is equivalent to x and y. So now we have 0, 11. Okay, that is our a intercept. Now we want our b intercept, which is like our x intercept, and that is when a equals 0. So 0 equals negative 2, and then 2b, plus 11. That is a b. We're going to minus 11, minus 11, minus 11 equals negative 2b, divide by negative 2, divide by negative 2. We're going to get b equals 5.5. Okay, So now we have our b-intercept, which is 5.5 and then 0. Okay, perfect. We are ready to graph. Before we move on, let's go deal with these inequality symbols and understand them. This right here, when b is, what does that mean right here? And when b is this, okay, I'm going to tell you, this equals greater than. Okay. This, with a line under it, equals greater than or equal to. And in contrast, this equals less than. And then this one equals less than or equal to. Okay, take a screenshot of this and memorize this. This is very important. This is very important to graphing and to some of the word problems on the test. Screenshot this. Write this down. Memorize this. It confuses me too. Don't worry. Stuff like this confuses me, and I still won't be able to get it unless I look it up. Okay? All right, moving on to graphing. We need to understand that so we can understand the statements. Okay, here's my graph. And then the a-axis is equivalent to the y-axis, and the b-axis is equivalent to the x-axis. Okay, so we have 0, 11. So I'm just going to make 11 like right here. Okay, and then 5.50, that's here. So I'm going to put it like right here. 5.5. All right. Have my point right here like this. I'm going to do my best to draw a line in between. Ooh. Got it. Okay. Perfect. So now let's test each statement. When b is greater than 3, a is positive. When b is greater than 3. Okay. So 3 is like right here, okay? 3 is like right here. And I'm going to use green. 3 is like right here. So greater than 3, so we have, let's say, 4, right? That's definitely positive, right? This is positive, right? We're on the b. When b is greater than 3, before we used to deal with stuff all in a terms. But now we're on the b-axis, the x-axis. Okay, so like for example, 4, right? We go up, it's a little slither, but then if we go up, we touch the line, we go this way, and it's gonna still be positive. A is positive. But let's say we go here to like 12, right? We pick a point, it's still greater than 3. Okay, I won't pick negative 12 because that is not greater than 3. I have to choose numbers or values greater than 3. So I chose greater than 3, which is 12. And then if we go down to the line, it's right here. And then we see that it becomes negative. It's a negative a value. So this is incorrect. Okay, it's positive for a little bit, but then as we increase more, it becomes negative. When b is less than 3, so anything less than 3, a is negative. So let's choose 2. Okay, that's less than 3. And we go up, and we see that it's positive, right? We see that it's a positive number. And if we chose like -1, we go up. It's still a positive number, a positive A value. So if you notice, anytime I choose anything that's less than 3, it's always going to be positive. Okay, let's say that's -20. That is less than 3. Go all the way up, try to touch the line somewhere, because it's gonna touch the line out where we can't see it, right? And it's always gonna be a positive value. All right, so this is incorrect. Okay, now we're gonna move on to something that's familiar. When A is less than 11, B is less than 0. Okay, this gets a little confusing, but let's work through it. When A is less than 11, so let's choose 10. Or I'm going to use a different color here because now we're going to be dealing in terms of A. I'll use orange. So let's say when A is less than 11, so let's say 10. Okay, 10. Well, if we see here, we chose 10, then we go down here, well, it's above 0, right? It's not less than 0, it's above 0. If we keep going down, right, let's say like 5, okay, then we go here on the axis, on the line, then go down to the B axis, it becomes greater than 0. It doesn't become less than 0, it becomes greater than 0. So this is incorrect. I'll do one more for C, okay? Let's choose -5, right? We chose -5. If we go to the line here, then go up to the B axis, well, that number right here, this value, is greater than 0, right? So this statement is incorrect because we wanted to see in the statement, in order for it to be true, we wanted B values less than 0. Okay? Now, when A is less than 11, B is greater than 0. Well, we've already tested that, right? We found out any number that's below 11 is greater than 0 on the B axis. So we've already done that. And that is true. So the answer is D. All right. Perfect. And that concludes the continuing education algebra and functions practice problems, graphing linear equations to test statements. If you want me to do more problems like this and also increase the difficulty, just comment more graphs, please. And I will do that because I know that these are confusing. Check out my other videos where I do have a full-length practice test, as well as I do share my experiences with my previous interviews. Marky F baby out. I will see you in the next video. Bye.